Hey friends, Vincent here. Welcome to Fearless in Rust, where we make Rust clean and simple. Let's get into it. Today, we are stepping into the world of modern string ciphers with ChaCha20. ChaCha20 is not a block cipher like AES. It belongs to a different family, stream ciphers. A stream cipher encrypts data 1 byte at a time by combining the plaintext with a pseudorandom keystream using XOR. Instead of dividing data into fixed-size blocks, ChaCha20 produces a continuous stream of secure random-looking bytes. And here's why ChaCha20 matters. It's used in WireGuard, TLS, OpenSSH, messaging protocols, mobile apps, and modern security libraries. Whenever performance, simplicity, and strong security are needed, especially on devices without AES standard hardware acceleration, ChaCha20 is often the preferred choice. So, let's start with a big picture. ChaCha20 was designed by Daniel Bernstein as a successor to Salsa20. Its goal was simple: provide strong cryptographic security with high performance across all platforms. ChaCha20 does not rely on specialized CPU instructions. It performs consistently well on laptops, phones, embedded devices, and servers. Instead of encrypted blocks, ChaCha20 generates a keystream using three values: a secret key, a nonce, and a counter. The keystream is then combined with a plaintext using XOR. Encryption is simply ciphertext equals plaintext XOR keystream. No padding, no block alignment, just pure stream encryption. Now, here's an important rule. Never reuse the same key and nonce combination. If a nonce is reused with the same key, the keystream repeats, and that breaks security immediately. So, every encryption must use a French nonce. In production systems, ChaCha20 is often paired with Poly 1805 to provide authenticated encryption. But today, we'll focus on the core cipher to understand how stream encryption works in Rust. We'll use the crate ChaCha20. So, let's jump into Rust. And first, let's start with import what we need. So, we need first ChaCha20 crate. Then, in the cipher port, we need the key initialization vector init, that one. And because we need several, can you this syntax? And we also need the stream cipher in that way. Okay. Next, now we define three important things. The key, this is the secret used to generate the keystream. The nonce, a unique value required for each encryption, and the plaintext. So let's start with the key. I click say an example. Very great. So here, the star dereferences the byte string, so we get the actual fixed size byte array instead of a reference. Because many crypto crates require exact byte sizes to guarantee correctness, safety, and prevent invalid keylines at compile time. That's why here we dereference it directly. Okay, we are good for the key. Now the nonce. So here the same. of the text. So let's say press meeting. Because ChaCha20 is a stream cipher, we don't need padding or block sizing. We simply copy the plain text into a buffer. So let's declare a mutable variable, ciphertext, where we're gonna clone. Okay. Now, recreate the encryptor. This initializes the ChaCha20 cipher with a hierarchy and nonce. So let me encrypt. New method. Okay, so here the key is the key. Initialization vector for us will be the nonce. Okay, good. And now we can encrypt the data by applying the keystream. Encryptor, keystream, and here we need to put new label reference. Okay, now let's print the cipher. Encode like in my previous video. Yeah. Okay, going. First highlight. Example. Yeah, I know. I sure take reference here. Okay, we're good. Okay, so cargo an example. Yeah. Okay, now you can see this cipher. You just encrypt data. Okay, now let's decrypt. So decryption works the same way as encryption. Because XOR is reversible, applying the same keystream again restores the original plaintext. Decrypt variable. At this point, we just clone the ciphertext. And now let's declare the same way the decryptor, and let's use also the apply keystream. So here, decryptor. Yeah, good. Okay, and now just need to print a decrypted message. Decrypted text. Up. In my previous video here, we need to use this method to handle some special character. And here, check encrypted. Okay, and finally, we verify the correctness that way. Here we text. Decrypt. Okay. If everything is correct, we recover the original message exactly. So as you can see here, put meeting at midnight, put meeting at midnight. Okay, now this is where things get serious. Using ChaCha20 correctly means respecting a few simple rules. First, never reuse the same key and nonce combination. Doing so causes keystream reuse, which completely breaks security. Second, generate a French nonce for every encryption. Nonces do not need to be secret, but they must be unique. And third, when integrity is required, use authenticated encryption like ChaCha20 1305. Encryption alone protects confidentiality, but authenticated encryption also protects against tampering. Let's zoom out for a second. ChaCha20 is fast, simple, and highly secure. It avoids many implementation pitfalls and is naturally resistant to timing attacks. That's why it's widely used in modern protocols and security libraries. And under the hood, the idea is beautifully simple. Generate a secure keystream, combine it with plaintext using Zo, never reuse the keystream. So, here what you should take away. ChaCha20 is a modern stream cipher designed for real-world performance. It avoids padding, avoids block alignment issues, and performs consistently across all hardware. In this video, you have seen how to integrate ChaCha20 into real-world code using safe and well-tested libraries. Simple design, strong security, excellent performance. Thanks for your time. See you in the next one.